Hello students, I'm coming with a new video class of the topic electric field. Now we are going to discuss one important concept called electric dipole. What is electric dipole? Let me explain it first. In the last class we discussed what is Gauss's law, how to use Gauss's law, all possible application discuss. After you go to the video of Gauss's law, you should come to this electric dipole. Okay, first write the definition. Right, a combination of two equal and opposite charges, separated by a very small distance. A combination of two equal and opposite charges separated by a very small distance is an electric dipole. So I am drawing one electric dipole, this one. I am considering this distance as twice a, such that we can say from the center distance to each charge is a each. Now let me explain this point. They should be separated by a very small distance. Exactly what amount of distance we can consider? What should be the value of that distance that I am going to discuss? Okay. Actually, if two point charges are separated by a large distance, say for example they are separated by say 1 meter distance or 2 meter distance. If you want to calculate field because of them at any point, say somewhere here or somewhere here or somewhere here, then we will find field because of this plus q, we will find field because of this minus q, and depending on their direction we will add, we will subtract, meaning we will use factor method. In this case, we are not going to consider that they are separated by large distance, they are separated by very small distance. Very small meaning such that we cannot measure it. Say for example, I am looking at one atom. Say for example, one hydrogen atom present. Hydrogen atom carries one proton and one electron. Location of proton and location of electron exactly not known. Only thing that is known is they are lying within the atom. What is the size of the atom? Size of the atom is radius is always of the order of 10 to the power minus 15, and radius of the nucleus and radius of the atom is of the order of 10 to the power minus 10. So this proton and electron in hydrogen atom must lie within the distance. So it is lying somewhere between 10 to the power minus 10 to 10 to the power minus 15. Clear? Now that small distance we cannot measure, we cannot visualize by our naked eye. So in that way, that kind of distance, clear, we consider as too small, of the order of 10 to the power minus 10 to 10 to the power minus 15, very very small of the size of that atom. In that case, we consider that positive charge and negative charge separated by a small distance of that kind is forming one electric dipole. Okay, this is important. Once you know the definition of electric dipole, clear, you should know two important lines. Clear? A line passing through these two charges, actually these are called poles, one negative charge and one positive charge. That is why together dipole, di meaning two. So if you consider a line passing through them directly, this line, clear, this is called axial line, meaning this is the axis of the dipole. And if you draw a perpendicular to the midpoint, clear, this line is called equatorial line. The word says equator, meaning equal distance from both the pole. From minus q whatever distance, from plus q also distance is same. It is also called perpendicular bisector. Why? Because this is the axial line, is the midpoint, we are bisecting at the middle perpendicularly, so perpendicular bisector. So these two axes are very important for us. One is what is axial line and what is equatorial line. Okay. After that we have to discuss one very important definition called electric, you write first electric dipole moment. Electric dipole moment. Electric dipole moment shown by the letter P, and it is a factor. I am giving factor sign. Why it is factor I am going to explain. First note the definition. Electric dipole moment. Right. Electric dipole moment of a dipole is defined as, write the sentence, electric dipole moment of a dipole is defined as the product of is defined as the product of either charge and the separation between them. Product of either charge and separation between them. Meaning this minus q or plus q, they are of same value, so either charge, meaning any one, into separation between them. It is a vector quantity. It is a vector quantity whose direction is considered from negative charge to positive charge. Whose direction is considered from negative charge to positive charge. Okay, let me explain why direction is of this kind. Clear? First of all, this is the dipole. This distance is too small, of the order of size of an atom, so we cannot consider anything inside. We just cannot see a point inside. Okay. If you consider a point here, say 1 coulomb charge I am considering because I want to get field at this point. This minus q will attract it and this plus q will repel it. Repulsion because of plus q will be less. Why? From here plus q at a larger distance. So ultimately field will be towards right. No difficulty in that. If you consider any 1 coulomb here, because of plus q it gets a repulsion, because of minus q it gets one attraction, but small attraction. Why? Because distance of this minus q is large. So in this case also field will be towards right because resultant force will be gathered towards right side. So that direction from minus q to plus q, direction is always minus q to plus q, gives the direction of dipole moment because an electric dipole always creates field along this line. We cannot consider a point inside because this distance is too small, of the order of an atom. We just cannot see what is happening inside. Okay. Now we know electric dipole moment. Electric dipole moment is a vector quantity. Now based on this electric dipole moment, you will get some question to find electric dipole moment. I want to show one such question first. You write, figure shows, you write it first, I am going to draw the figure. Figure shows a square of side L. Figure shows a square of side L with 4 point charges at the corners. With 4 point charges at the corners. If L is small, meaning this distance, find the electric dipole moment associated with the combination. If L is small, find the electric dipole moment associated with the combination. Meaning we have to find what is P. Now to find electric dipole moment, two methods possible. I am going to show both the method one by one. So this is the original question. I am drawing it here separately. Here minus 3q present. I am just considering, instead of 1 minus 3q, I am assuming 3 minus q charge kept together minus 3q. 1 plus q here, 1 plus q here, 1 plus q here. Mathematically no mistake done. This minus q and this plus q forms a dipole in this side. I am writing P1. Value of this one is q into L. Dipole moment is q into separation. Here separation is L. In my original explanation, separation was twice. Direction always from negative charge to positive charge. Similarly, this minus q and this plus q will form a dipole in this side. Clear? I am writing P2. Value of this one also same, q into L. This remaining minus q with this plus q will form a dipole in this side. This dipole is q because either charge plus minus not required. Separation from here to here is root 2L. So these are the three dipole present, but we have to get dipole moment associated with the whole combination. So dipole moment vector quantity, we have to go for their vector sum. So 1 P1 present in this side, 1 P2 present in this side. As P1 and P2 exactly same in magnitude, yeah, angle between them is 90 degree. Resultant will pass to the middle by making an angle 45 degree. Yeah, so this is the resultant of P1 and P2. And already in this side P3 present. So total dipole moment I am going to write. I hope no problem in the writing. So total dipole moment I am writing. It is dipole moment P1 and 2 plus P3. But 1 and 2 lying at 90-degree angle, so resultant of these two is under root p1 square plus p2 square plus twice p1 p2 cos of 90 plus p3. If you put the value cos 90 is 0, no need to write p1 p2 known, so I am just writing and simplifying. It is root 2 ql. p3 is also q into root 2l, so answer is 2 root 2 ql. So this is the total dipole moment. Clear? Direction of the dipole moment is along the diagonal. Direction will be along the diagonal. Along the diagonal. I hope this is clear. So this can be done by one other way also. Clear? That other way I am going to explain. It is quite interesting. We can do it in some other way also. The other way is, I am drawing it here. Just alternate method. Here minus 3q present. Here q present, here 1 q present, and here 1 q present. Together of these three positive charges also plus thrice q, equal and opposite charges, minus 3q and plus thrice q. Problem is this thrice q not lying at a single point. They are lying like this. We know in case of class 11 mechanics, there is a point called center of mass, where different masses if lying, we can assume whole mass to be present. If you use the same idea here, instead of these three charges, we can identify a center of charge, like center of mass. Then this 3q can be considered at a point, and this thrice q at a point, and minus 3q together will form the dipole directly. So I am going to show that idea. Clear? Now I am not concentrating on this minus 3q. I am considering center of these charges. So look at these two, 1q here and 1q here. Their center will be exactly at the middle. So instead of this q and this q, you consider 1 twice q at the center. Meaning, in comparison to this q and q, twice q is the center of charge. Like, if one mass present here and one equal mass present here, their center of mass at the middle. Center of mass meaning, we can assume whole mass, meaning twice m present at the middle. Here, whole charge, twice q present at the center of charge. Okay. 1 twice q here and 1 q here, their center will be somewhere here. Why? If one heavy mass present and one lighter mass present, center will be always towards the heavier one. So center of charge will be somewhere here. If you can measure location of this center of charge, clear? Center I am writing. If you know this distance, clear? Then dipole moment comes out, because here we can assume whole charge present. Clear? Whole charge q, q and q we can assume to be present at this point. So how to get that center of charge? For that, let me show the calculation. I am just showing the step. Just be careful. It is simple calculation. In case of center of mass, formula is RCM equal to m1 r1 plus m2 r2 divided by m1 plus m2. I am finding center of mass. Sorry, I am not finding center of mass, I am finding center of charge for these two, twice q and q. I am measuring from minus 3q. So I am finding that center. Here, from here I am measuring twice q present at this distance. What is this distance? Half of the whole distance. Whole distance of the diagonal is root 2l, half of that. So l by root 2 plus this q present at this distance. It is q into root 2l divided by total charge, of course thrice q. Thrice q, why? Twice q and q. After calculation, what you get? Root 2 and 2 after cancellation, it is 2 root 2 ql by thrice q. Q goes cancel, so it will be 2 root 2l by 3. So I am drawing separately. Here minus thrice q already present. Instead of Q here and Q here, we consider thrice Q present at a point here, thrice Q. This distance is our R. Now forget about the previous thing. Whatever given in the question, forget about that. We are just close to get the answer. So one minus 3Q and one plus 3Q present here. Plus 3Q is directly not present at this point. We are using the concept of center of mass to get what is center of charge. Okay. So dipole moment is either charge, meaning either this minus 3Q or this plus 3Q into R. What is that? 3Q as it is, R just calculated as 2 root 2 L by 3. 3 goes cancel, it is 2 root 2 QL. That was the answer which is previously calculated. So we can get the answer by actual calculation of point charges, or we can also identify the same answer, also get the same answer by using the concept of center of charge, like center of mass used in class 11. So this idea I want to extend further. The same idea I want to extend further with questions. One more question. Here I am showing one more question here. So this is x-axis, this is y-axis. Write the question first. Figure shows a coordinate system. Figure shows a coordinate system where 4 point charges. Figure shows a coordinate system where 4 point charges are kept. Where 4 point charges are kept as shown. Where 4 point charges are kept as shown. Find the electric dipole moment of the combination. Find the electric dipole moment of the combination. Okay, question writing over. Look at the figure. In this figure, if you look at total positive charge, plus 4Q and plus twice Q, 6Q. So total positive charge is plus 6Q. Total negative charge, minus Q and minus 5Q is minus 6Q. So here also equal and opposite charge present. Problem is positive charge is not at a particular place. Similarly negative charge also not a particular point. So if you can find location of center of charge for positive charge and location of center of charge for negative charge, we can think of calculating electric dipole moment easily. Okay. So I am showing the solution. Here I am finding first axiom. M1 x1 plus M2 x2 divided by M1 plus M2. This is the idea to find x coordinate of center of mass. Along x coordinate only positive charge present, so this will give us location of positive charge only. We have to calculate location of positive and negative charge separately. First for positive charge, I am doing from the origin, so twice Q at the left. So it is twice Q into minus thrice L. 4Q at the right of the origin is positive. So 4Q into thrice L divided by total charge. We are not writing with mass, we are writing with charge. Total charge is 6Q. So calculation gives us minus 6QL plus 12QL by 6Q. So I think L only. So the positive charge 6Q will be present at a distance L from the origin on x-axis. X coordinate calculated. X coordinate is nothing but the location of positive charges. Location of negative charges I want to find. Clear? Same idea. It is M1 Y1 plus M2 Y2 divided by M1 plus M2. M1 Y1 plus M2 Y2 divided by M1 plus M2. Location of Y coordinate we are doing. Just let me complete the calculation. Okay. It is that charge is negative minus q, distance is twice L. This charge also negative minus 5q, distance is below origin, so minus 4L divided by total charge minus 6q. If you do calculation, minus twice QL plus 20QL divided by minus 6q. So what you get? 18QL by minus 6q. Q goes cancel, I think minus 3L. So let me draw it with this location of center of mass. The positive charge plus 6q is lying at a distance L, because the center of mass for positive charge comes out plus L. For negative charge, it is coming minus 3L. So from the origin, minus 3L meaning somewhere here. So here minus 6q present. So we know one combination of equal and opposite charges present separated by this distance. If this distance is d, dipole moment value will be either charge, meaning either this minus 6q or plus 6q. Separation is d. What is the d? This d you can write as under root, Pythagoras principle, 3L square plus L square. I think root 10L. So it is 6 root 10 QL is the dipole moment. This is the value of the dipole moment. If you are interested in showing the direction of dipole moment always from negative charge to positive charge. So direction of dipole moment is this one. To show, we can measure this angle. Clear? Let me measure this angle. I am writing from the figure what is tan theta. Tan theta is perpendicular by base, meaning L by thrice L, so 1 by 3. So theta equal to tan inverse of 1 by 3. Here we are measuring theta equal to tan inverse of 1 by 3, the direction. So direction we can write like this. The required direction makes an angle. Theta equal to tan inverse of 1 by 3 from y-axis, because we measure it from y-axis. From y-axis it makes angle tan inverse of 1 by 3. Clear? At the time of doing calculation, magnitude how to find, direction how to find, we discuss. Any kind of question with point charges possible, all about considering location of center of charge like location of center of mass. Clear? Once the idea known, the dipole moment for point charges very easy to calculate. If it is not point charges, big size object, how to do that I am going to show in the next class. Okay, this class is over. Go through it.